Today's video is on the problem related to Laurent series, and this topic is from complex power series. And in today's video we are going to find out the Laurent series expansion of 1 by z square minus 4z plus 3 for the region 1 less than mod z less than 3, and the second region here is mod z greater than 3. It's very clear that from the function f of z is equal to 1 by z square minus 4z plus 3. Now I am going to take the factors of this. This is z square minus 4z plus 3. Now this minus 4z I am writing as minus 3z minus z. See here, minus 3 minus 1 is minus 4. This is plus 3. Now if I take z common from these two, this will be z minus 3. So if I take minus common from this will be z minus 3. So if I take z minus 3 common, see here, z minus 3, this will be z minus 1. Clear? So f of z, I can write this as, see here, z minus 1 into z minus 3. So this is z minus 1 into z minus 3. Now I am going to split this as f of z is equal to, see here, f of z is equal to, this is a by z minus 1 plus this is b by z minus 3. Now I am going to resolve into partial fractions and find out the values of a as well as b. Z minus 1 into z minus 3 is written as a by z minus 1 plus b by, this is z minus 3. Now this is 1 by, this is z minus 1 into z minus 3 is equal to. So if I take LCM here for z minus 1 and z minus 3, this will be a times of z minus 3 plus this is b times of, this is z minus 1. Now if I cancel the same thing from numerator, from the denominators of both sides, then 1 is equal to a into, this is z minus 3 plus b times of z minus 1. So I need the values of a as well as b. So this is minus 1. So if I keep z is equal to plus 1, so if I keep z is equal to plus 1, what happens here? This will be 1 is equal to a times of 1 minus 3. 1 is equal to a times of minus 2, and therefore a value is equal to minus half. So I got the value of a as minus half. And next one here, this is minus 3. So if I put z is equal to plus 3, if I keep z is equal to plus 3, then see 1 is equal to 0 plus b times of, this is 3 minus 1. 1 is equal to, this is 2b, and b value here is half. So the b value we got as plus half and a value as minus half. So in this I am going to substitute a as minus half and b as plus half. Therefore our f of z value here, so this value a as minus half, b as plus half. Therefore we got the value of f of z here as, I am writing f of z is equal to, so this is minus half by z minus 1 plus half by z minus 3. Clear? After substituting, so our f of z value is this one. Therefore f of z is equal to, so if I take half common plus half common, so I am going to write z minus 3 minus z minus 1. Clear? And therefore, so this is our function. So our function is like this, as f of z is equal to, so if I take plus half common, so this will be half times of, this is 1 by z minus 3 minus 1 by z minus 1. Clear? And therefore our region, the first region here is given as 1 less than mod z less than 3. See here, what is the region given? This is 1 less than mod z less than 3. So for solution 1, so this will be the solution 1. This is for solution 1. See here, for this f of z, f of z is equal to, so this is half times of, so this is z and this is 3. So which one is bigger? 3 is bigger. So among z and 3, I am going to take 3 common. So if I take minus 3 common, this will be 1 minus z by 3. Clear? Among z and 1, see here, z and 1, which one is bigger? Z is bigger. So in this case, I am going to take z common. So z, if I take common, this will be 1 minus 1 by z. Clear? Now f of z can be written as, this is half times of, this is minus 1 by 3 into 1 minus, this is z by 3 inverse, and this is minus 1 by z times of 1 minus 1 by z inverse. Now if I multiply with half, this will be minus 1 by 6 times of 1 minus, this is z by 3 inverse, and this is minus 1 by z times of, this is 1 minus 1 by z inverse. So if I multiply with 2, this will be 2z. And we have one expansion here as 1 minus x. So 1 minus x, x inverse can be written as here minus and here minus. So everything will be plus 1 plus x square plus x cube and so on. Now I am going to apply that expansion. Therefore, f of z is equal to minus 1 by 6 times of 1 plus, this is z by 3, z square by 3 square plus, this is z cube by 3 cube plus and so on, minus 1 by 2z times of 1 plus, this is 1 plus z plus 1 plus z square plus 1 plus z cube plus and so on. So f of z can be written as minus 1 by 6 times of 1 plus z by 3 plus z square by 9 plus and so on, minus 1 by 2z times of 1 plus 1 by z plus 1 by z square plus and so on. So for the region 1 less than, so this is 1 less than mod z less than 3. And the next thing here is, the second condition here is mod z greater than 3. See, this is also so simple. So this is also so simple that, so here is f of z. So our f of z value is like this. So f of z is equal to half times of 1 by z minus 3 minus 1 by z minus 1. Clear? And here our condition here is mod z value is greater than 3. So this is a solution 2. So for the solution to see what I am going to do, see in this expansion, f of z is equal to, so f of z is equal to, this is half times of 1 by z minus 3 minus, this is z minus 1. Clearly, f of z is equal to half times of, among z and 3. So this is z and 3. So which one is greater? Z is greater. So in this case, we have to take z common. That is 1 minus, this is 3 by z. Clear? So if mod z is greater than 3, it is still greater than 1 also. It is still greater than 2, still greater than 1. So when you compare with z and 1, so z here and 1, which one is greater? Among z and 1, z is greater, and therefore I am taking z common from this, 1 minus 1 minus z. So this is the shortcut which you have to use. So f of z will be, if I send, so this can be written as 1 by z times of 1 minus 3 by z inverse minus 1 by z times of 1 minus 1 by z inverse. So if I send 2 inside, see what happens. This will be 1 by 2z times of 1 minus, this is 3 by z inverse, and if I send 2 inside, this will be 1 by 2z times of 1 minus z inverse. And again we have the expansion like this, that is 1 minus x inverse can be written as 1 plus x square plus x cube plus and so on. Now I am going to consider this as 1 minus x inverse and 1 minus x inverse. Now f of z is equal to 1 by 2z times of, this is 1 plus 3z plus 3 square by z square plus this is 3 cube by z cube plus and so on, minus 1 by 2z times of 1 plus 1 by z plus 1 by z square plus 1 by z cube plus and so on. So This can be written as f of z is equal to, if I take 1 by 2z common from these two, this is nothing but 1 plus 3 by z plus, this is 9 by z square plus 27 by z cube plus and so on. Here this will be minus 1 by z minus 1 by z square minus 1 by z cube and so on and so on. So this is for the condition mod z greater than 1. So this is the Laurent series expansion. See, let me explain you the question here. The question here is like this. So this is the function f of z is equal to 1 by z square minus 4z plus 3. So I have split into factors and these are the factors, and after splitting into the factors I have resolved into partial fractions and I have found out the value of a as well as b and substituting a and b values, and this will be f of z value. So our f of z value is this one. F of z value is this one. So the condition here is 1 less than mod z less than 3. So among z and 3, compare 3 is greater 1. So I have taken 3 common. Among z and 1, z is greater and they have taken z common. And so this is the expansion I have used, and this is the final answer for 1 less than mod z less than 3. And the second case here is mod z less than greater than 3. So if it's greater than 3, it is even greater than 1. So this is the continuation part. And among z and 3, which one is greater? Among z and 3 z is greater. So I have taken z common, and among z and 1, z is greater 1. So I have taken z common, and I have used this expansion, and after expanding, this is the expansion using Laurent series for the region mod z greater than 3. Hope you all guys understand. It's very clear if you go through the video, and please practice and pass it on to your friends and subscribe to this channel before you practice.